So we're going to go through the step-by-step process of drawing a Lewis structure for a molecule with the correct molecular geometry. So we're going to start by drawing a dot diagram. So you remember how to draw your Lewis dot diagrams for individual atoms. I'm going to go find my number of valence electrons. So if I find beryllium, I see that beryllium has 2 valence electrons. It's in group 2. So I draw 1, 2. And then I've got 2 fluorines. I'm going to go ahead and stick my fluorines right above those 2 electrons that beryllium has, because I know that's where it's going to bond. So fluorine has 7 electrons. It's in group 7 valence electrons. It's in group 17. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Remember, first we draw them singular, then we pair them. You'll notice I left the singletons next to each other, and that's because I know that's what's going to make the bond. Once you do a few of these, you'll kind of get the hang of it, and you'll be able to draw them a little neater. So if I have 2 singleton electrons, beryllium and fluorine are going to share those to make an electron pair, because an electron pair is more stable than a single electron. They have opposite spins. So whenever you have 2 singleton electrons, one on one atom, one on the other, those are going to be shared in a bond. So this here is a bond. So then I want to count my number of electron domains around the central atom. Just the central atom. I don't care what's going on with fluorine. Beryllium's the central atom. It's the one I care about. So I've got 1 area of electrons, 2 area of electrons. No lone pairs. I just have 2 bonds. So 2 electron domains. If we remember from our electron domains, or you can use your chart, I would recommend using your chart. Mine is white here, yours is blue. So your chart with your electron geometries. That would be a linear geometry. And since there's no lone pairs, the molecule geometry and the electron geometry will be the same. So it'll be linear. So that means when I write it over here, I write my central atom beryllium. I want to draw it as a linear compound. So I can draw those bonds as just a line. And I'm still going to draw my remaining electrons. Hopefully your dots will come out like dots and not like lines. I can ignore my lines on this fluorine, just the way it came out digitally. So that's one easy Lewis structure. No lone pairs. So let's look at an example where we do have some lone pairs. So I'm going to come down to Ni3 here, nitrogen. So again, I'm going to draw my Lewis dot diagrams for what I've got here. So I've got nitrogen, 1, 2, 3, 4, 5. So it's got 5 valence. It's in group 15. And my iodines, I have 3 of them, and they all have 7 valence electrons. They're in group 17. So again, notice how I am drawing those singletons next to the other singletons, because I know that's where my bond is going to form. So I got 7. So that's going to give me 1 bond, 2 bond, 3 bonds. So single electron shared with another single electron creates a bond. So a bond is 2 electrons. Notice I've got on this nitrogen this little lone pair left over. So I'm going to put a little alien head around that. That's a lone pair. Now, we don't want to have single lone electrons. We only want lone pairs of electrons. Again, opposite spin, that's how they're stable. They got to be paired up. So if I count all these up, I have 1, 2, 3 bonds plus 1 low pair. So that's 4 electron domains. So that's actually a tetrahedral electron geometry. So then if I go to my chart and I find a tetrahedral geometry with 1 lone pair, it's a trigonal planar. I'm going to abbreviate that. Trigonal planar molecule geometry. Now I'm actually going to sketch out that geometry there. So E on our paper represents the central atom. And then we've got X X. And then this one is wedged. This one, oh, sorry, this is trigonal pyramid, my bad, not planar. Trigonal pyramidal. We got one that is dashed back, and then your lone pairs here. Okay, so then how that translates is instead of writing E, I'm going to write N, because that's my central atom. And instead of these X's, I'm going to change them to I's. And I'm going to draw the leftover valence around them. Edge it out. So you notice all I'm doing is I'm just taking that picture from our chart and I'm just inserting the atoms I have in the compound I was given. And that's it. That's the correct Lewis structure with geometry. So I started by drawing my dot diagram. My dot diagram tells me how many electron domains I have and how many lone pairs I have, which gives me my molecule geometry. And then I just plug in the actual atoms into my molecule geometry, and you're good to go. There's your Lewis structure with the proper geometry.